What if I told you the next big threat to Tesla isn't another EV, but an engine that doesn't need batteries at all? And here's the kicker. It comes from Toyota, the same company everyone thought was falling behind in the electric race. In one announcement, they've flipped the script, revealing a hydrogen-powered beast designed to crush EV weaknesses. Lightning-fast refueling, massive range, and performance that doesn't fade with age. No waiting hours at a charger, no battery degradation, just fill it and go. The reveal was so sudden, even industry insiders didn't see it coming. Toyota's CEO didn't tease it. He didn't leak it. He simply walked on stage and dropped a bombshell big enough to make Elon Musk look twice. Within hours, Toyota's stock was climbing, and analysts were scrambling to figure out what this meant for the future of cars. But here's why this matters to you. This isn't some niche prototype for the rich. Toyota is building it to go mainstream, and it could completely change how you drive, fuel, and even think about your car. So, what exactly is this machine, and why are the biggest names in the auto industry suddenly nervous? No leaks, no hints, no warning. Out of nowhere, Toyota's CEO walked on stage and dropped a bombshell the world wasn't ready for. A hydrogen combustion engine built to go head-to-head with electric vehicles and win. The timing? Brutal. Every major automaker was knee-deep in battery development, fighting over lithium and racing to install charging networks. Meanwhile, Toyota was quietly building something entirely different. And in a single reveal, they forced the whole industry to hit pause and rethink. The market's reaction was instant. Toyota's stock jumped. Analysts who had been betting everything on an all-EV future started rerunning the numbers. And here's why. This isn't just another clean energy pitch. Toyota claims this engine can match, even beat, the best EVs on performance, with zero CO2 emissions. That's not competition for Tesla, BYD, and the rest. That's a direct challenge. So what did they build? A 1.6-liter, 3-cylinder turbo hydrogen engine tested in the GR Yaris and GR Corolla. 261 horsepower, racetrack proven, and thermal efficiency near 45%. And the best part? It keeps the raw EVs lost. But here's where it gets dangerous. It attacks EV weaknesses head-on: range, refueling, weight, and could make charging feel like a thing of the past. And this sudden strike wasn't born overnight. It's the result of a secret, decade-long campaign few outside Toyota ever knew existed. It began quietly in 2015, under a project name no one outside a tight inner circle had ever heard. Genzai. Publicly, Toyota appeared to be focused on hybrids and EVs. Behind closed doors, engineers were pushing hydrogen engines to their limits in brutal endurance races, gathering real-world data no lab could match. The early prototypes had a fatal flaw: hydrogen pre-ignition. The solution came years later, a breakthrough injector design capable of delivering precision fuel flow at ultra-high speeds, eliminating the risk entirely. This was no lone effort. Toyota tapped into Japan's energy giants, forging long-term partnerships to build a fuel supply chain before the rest of the world even considered it necessary. For the high-pressure tanks, capable of withstanding both extreme impact and intense heat, Toyota didn't look to traditional automotive suppliers. They looked to aerospace. The same material science used in rocket fuel tanks now shields their hydrogen systems. And all of it was hidden from the industry, not to protect patents, but to keep competitors from realizing just how far ahead Toyota already was. While most automakers doubled down on batteries, Toyota's board committed to what they call a multi-path strategy. That means developing electric, hybrid, and hydrogen vehicles side by side, with no single technology holding the company hostage. In rural markets where charging networks barely exist, EV adoption has stalled. For long-haul fleets, every minute spent waiting for a battery to charge is revenue lost. Toyota's answer: keep EVs for short-range urban markets, keep hybrids for transitional buyers, and unleash hydrogen where downtime is a deal-breaker. Taxis, buses, logistics trucks, industrial transport, these aren't niche use cases. They're the backbone of global mobility, and Toyota isn't pitching hydrogen as an alternative. Internally, they call it the need of the future, the safety net when battery supply chains hit bottlenecks. The economics are where this plan becomes truly dangerous to their competition. Today, a hydrogen combustion engine costs about 20% more to produce than a petrol ICE, but it's still roughly 40% cheaper than an EV drivetrain. And Toyota doesn't have to scrap its existing manufacturing empire. Retooling an ICE factory for hydrogen is a fraction of the cost of building an EV plant from scratch. That means they can scale faster, much faster. The initial goal: 100,000 units a year. The 2030 target: 1 million hydrogen-powered vehicles rolling off global production lines annually. And they're not just thinking about new buyers. Engineers are deep in R&D on retrofit kits, systems that could take an existing petrol-powered car or truck and convert it to hydrogen. If they pull that off, Toyota could tap into a used vehicle market hundreds of millions strong, turning existing fleets into low-emission machines without replacing them entirely. Just as critical, hydrogen sidesteps the most volatile parts of the EV supply chain. No dependence on cobalt, nickel, or lithium. With geopolitical tensions squeezing rare earth metal supplies, that's not just an advantage. It's a shield against the next global shortage. But even with cost and supply chain on their side, Toyota knows mass adoption lives or dies on one thing: fuel availability. That's why their infrastructure push has been just as aggressive as their engine program. Japan already leads the world with over 120 operational hydrogen stations, and in Tokyo, pilot fleets of hydrogen-powered taxis and buses are stress testing daily, refueling under peak urban conditions. But Toyota isn't stopping at home turf. In Europe and North America, they've locked in partnerships with heavy hitters like Shell and Air Liquide to accelerate rollout. The United States plan starts where adoption is most likely: California, with LA, San Francisco, and San Diego set to become anchor points in a West Coast hydrogen corridor. For markets where permanent infrastructure isn't viable yet, Toyota is deploying mobile refueling trucks, essentially hydrogen stations on wheels, capable of servicing fleets in rural or remote regions. Meanwhile, they're attacking the cost barrier head-on by building dedicated green hydrogen production facilities. In Hokkaido and Texas, new plants will use solar and wind to split water into hydrogen, cutting fuel costs and eliminating the carbon footprint tied to its production. This isn't just about selling cars. It's about controlling the supply chain from molecule to motor. The announcement has sent shockwaves through the auto industry. Hyundai, already experimenting with its Nexo hydrogen SUV, is accelerating its heavy-duty hydrogen truck program to keep pace. BMW, Honda, and Volkswagen are sitting in what industry insiders call watch-and-learn mode. But their internal R&D teams have started contingency projects in case the hydrogen wave turns into a flood. Tesla's public stance remains unchanged. Elon Musk continues to mock the concept as full cell technology. But behind the scenes, suppliers are quietly reporting inquiries from Tesla's procurement team about hydrogen components. In China, automakers aren't waiting to see what happens. Several major brands have moved to lock in long-term hydrogen supply contracts before prices spike, mirroring the early lithium land grab of the EV boom. Even oil and gas giants, the same companies that once saw EVs as an existential threat, are pivoting toward hydrogen. They're betting that the distribution networks they've built over decades could be repurposed to deliver this new fuel, keeping them relevant in a post-petroleum world. And then there's the political tailwind. Hydrogen from renewable electrolysis can slash total life cycle emissions by up to 90%, putting it squarely in the sights of global climate policy makers. Japan has already baked it into its 2050 net zero pledge, and the European Union is actively debating whether hydrogen combustion should be classified as a zero-emission technology for regulatory purposes. If that happens, entire categories of vehicles currently restricted by emissions rules could get a free pass. In India, the timing couldn't be more perfect. The national green hydrogen mission is ramping up, and Toyota's roadmap aligns almost point for point with the government's objectives. Subsidies, tax exemptions, and targeted fleet conversion incentives are on the table, exactly the kind of support that could make hydrogen economically competitive with EV charging. Across multiple continents, policy shifts are forming the runway Toyota needs for takeoff. If those shifts accelerate, the speed of hydrogen station rollouts could jump from years to months, collapsing one of the biggest barriers between concept and mass adoption. But even with political winds at their back, the journey is far from guaranteed. The promise is enormous, but the road to hydrogen dominance is anything but smooth. Right now, producing hydrogen fuel is still 3 to 5 times more expensive than simply charging an EV. Most hydrogen is made through electrolysis, a process that splits water into hydrogen and oxygen, using large amounts of electricity. And unless that electricity comes from renewable sources, the environmental advantage starts to weaken. Even when green hydrogen is used, the cost per kilometer can still be higher than a battery EV, especially in markets without subsidies. Then there's the infrastructure problem. Building a hydrogen refueling station isn't remotely comparable to setting up an EV charger. An EV fast charger might cost between 10 to 15 lakh rupees to install. A single hydrogen station can run between 50 crore to 100 crore rupees. These facilities need high-pressure tanks, explosion-proof pipelines, advanced safety monitoring systems, and specialized compressors, all of which drive costs through the roof. The sheer capital investment means that without government incentives, most fuel providers won't touch hydrogen distribution for years. Public perception is another hurdle. Hydrogen, to many people, still carries the image of volatility, the kind of fuel that could turn a crash into a catastrophe. Toyota's engineers have spent years countering that narrative, building tanks that can survive bullets, high-speed collisions, and extreme heat without rupturing. Tests show hydrogen disperses quickly into the air if leaked, reducing fire risk compared to petrol, but convincing the average buyer is another battle entirely. And even if all these engineering feats succeed, there's the issue of timing. Vehicle production might ramp up faster than the infrastructure can keep pace, leaving early adopters stranded in a fuel desert. For fleets, one missing refueling point on a route could render the entire operation unworkable. Layered on top of all that is the most unpredictable factor: politics. Subsidies and tax breaks make hydrogen more viable today, but political winds can shift fast. A change in government policy could freeze expansion overnight, collapsing the economics for both producers and buyers. Still, Toyota isn't operating on theory alone. They've been running real-world trials to prove the technology can work under pressure. In Tokyo, hydrogen-powered taxi fleets have been logging data for months, showing a remarkable 97% uptime compared to 83% for their EV counterparts. The difference comes down to downtime. Where EVs are sidelined for charging, hydrogen taxis are back on the road within minutes. In Australia's remote mining regions, where diesel trucks have long dominated, hydrogen-powered haulers have delivered a 35% reduction in operating costs thanks to lower fuel expenses and less mechanical wear. The motorsport arena, the ultimate torture test for any powertrain, has also played a crucial role. Toyota's hydrogen GR race cars have completed endurance events without major failures, proving the engines can handle sustained high-load performance without overheating or losing efficiency. Meanwhile, in rural logistics, small delivery fleets are reporting the one thing EVs have struggled to guarantee: no range anxiety. Even in harsh terrain and unpredictable weather, their performance remains consistent. Driver feedback has been unexpectedly enthusiastic. Many had feared the switch to hydrogen would mean compromising on acceleration or responsiveness, but most described the opposite: immediate torque, a satisfying engine note, and a sense of driving something powerful without leaving a cloud of exhaust behind. For fleet operators, the appeal is just as strong: lower downtime, competitive running costs, and a public image boost from adopting a clean technology. All of these trials feed into Toyota's broader vision for the future, a market where hydrogen and electric vehicles don't compete directly but dominate different segments. The plan is clear: use hydrogen for heavy-duty, long-range, and high-utilization applications, while EVs continue to serve personal and urban mobility needs. This dual-path approach avoids the one-size-fits-all trap that has limited EV adoption in certain markets. And Toyota isn't dabbling. They've already poured more than $70 billion into hydrogen R&D, infrastructure partnerships, and global production capabilities. That investment isn't just in engines and cars, it's in fuel plants, station networks, and industrial applications that could tie hydrogen supply chains to multiple sectors beyond transport. It's a long game, but it's backed by the manufacturing advantage Toyota has built over decades. With production facilities, suppliers, and dealerships spread across nearly every continent, they can mass-produce and distribute hydrogen vehicles far faster than a newer player like Tesla. That scale could prove decisive if and when hydrogen fuel costs drop. Green hydrogen production is already falling in price as renewable energy capacity grows, and once it reaches parity with EV charging, Toyota could unleash an avalanche of models onto the market without the bottlenecks that come with battery supply chains. In that scenario, Tesla's current refusal to enter the hydrogen space could go from bold conviction to strategic vulnerability, especially in sectors and regions where battery EVs are less competitive. It's the kind of industry race that doesn't have a single finish line. On one side, Tesla is doubling down on its EV ecosystem. Charging networks, battery innovation, and software-driven vehicles designed to integrate seamlessly with solar and energy storage. On the other, Toyota is betting on diversification, aiming to be everywhere batteries can't reach while still competing in the EV space when it makes sense. The outcome may hinge not just on engineering, but on which strategy adapts faster when the market shifts, and shift it will. Whether that tipping point comes from a breakthrough in hydrogen production, a geopolitical disruption in battery supply chains, or an infrastructure leap in key markets, one thing is certain. Both companies are positioning for a fight that will define the next era of mobility. For Toyota, hydrogen isn't just another powertrain. It's the wild card that could rewrite the rules of the game. And for Tesla, ignoring that wild card might be the biggest risk of all. The hydrogen revolution might just be starting. And if Toyota's right, the entire EV playbook is about to be rewritten. If you want to stay ahead of this shift, before the headlines catch up, make sure you hit that like button, subscribe, and turn on notifications, because the next move in this tech war could drop any day now.